Let's look at practice problem 5-2. Again, we're going to analyze this very simple three-member truss by hand. First thing, of course, let's look at the truss, make sure that all the loads are on the pins. Both loads are on pin B. That means we can analyze this structure as a truss. All the nodes, all the joints are labeled, A, B, and C, and all the dimensions are given. So our next step is to determine the two angles at pin A and at pin C. And if I know those, the angle at pin B will just naturally fall out, but we're not going to use that one. Okay. Let's just look really quickly at pin number A. And this keeps on going, but I know this height is given as 10 feet. This distance is given as 8 feet. So angle A is simply the inverse tangent of opposite over adjacent, 10 over 8, and that equals 51.340 degrees. Similarly, angle C has the same height, and its adjacent side is given as 16 feet. So C is the inverse tangent of 10 over 16. Opposite over adjacent. There's the opposite, there's the adjacent to angle C. And again, these are both 90-degree angles. 32.005 degrees. And I will keep that much precision. Okay. Now I know all the geometry that there is to know about this triangle, or about this truss, excuse me. Our next step, find the reaction forces. So I will look at this structure as if it's one solid piece, and since there is a pin at A, we will draw two forces in a roller at C. Again, I will call this CY, AY, and AX. In addition, I have a 5 kip load here and a 10 kip load there. I also know that this distance, if I extend the line of force straight down, there's my 10 kip, and if I extend this line of force in both directions, that 5 kip is 10 feet away. Okay, so let's look at a couple moment arms. This is 8 feet. This is 10 feet. So if I sum up the moments about A, I end up with moment arm of 10 times force of 5. And again, that moment is clockwise. And then I have plus a moment arm of 8 times a force of 10. And again, whoops, that moment I want to draw that in red, is also clockwise. And then finally, I have a counterclockwise moment. This is 8 plus 16. That's 24 feet. So my moment arm is 24. And my force is Cy. Those all add up to 0. 50 plus 80 gives 130 kip feet, and that equals 24 Cy. So Cy is 130 over 24, or Cy equals 5.417 kips. Now I'm going to use the same approach, and I'm going to take the moments about C. Okay. If I look at C, my 5 kip force is still 10 feet away. I have a moment arm of 10 feet. To the 10 kip force, I have a moment arm of 16 feet. So let's start with that force. I have 16 feet times 10 kips. And that force goes counterclockwise. So I'm going to put a negative sign out in front of it. Next, I have a moment arm of 10 feet and a force of 5 kips, and that is clockwise. And then finally, across this distance, I have a moment arm of 24 feet and a force of AY, again clockwise, and those add up to 0. Moment arm 24, AY is the force. Moment arm of 10, 5 is the force. Don't forget that one. And then moment arm of 16, force is 10. And this one rotates the other direction. Causes rotation this way. This length causes rotation this way. And this length causes rotation this way. What about AX? AX has a line of force that goes straight through CY. So its moment arm is 0. Doesn't matter what AX is. Let's solve for my one unknown in this. 24 AY equals 16 times 10, 160. I flip it on the other side of the equal sign and I change its sign, so that's a positive 160. This 10 times 5 becomes negative 50 on the other side of the equal sign. 110. AY equals 110 over 24, or 4.583 kips. Okay, that's everything except AX. So CY 5.417, AY 4.583. And what about AX? Well, if we sum up all the forces in the X direction, I have an AX plus 5 equals 0. That tells me right away AX is minus 5 kips, meaning AX is actually pointing the other way. And I will draw it that way when we get along to analyzing those joints. That's a lot going on just to find out the reaction forces. Not trivial. But those are 3 results. Now we can move on to looking at the individual joints. I have 3 joints, and I have 3 members, so I only need to analyze 2 of those to get all of the joints, or all of the members. Again, I'll start out with point A. And at point A, I have a force of 4.583. 4.583 going this way. I have a force of AC going to the right. I have a force of 5 going to the left, or a negative 5 going to the right. And then I am going to just start by breaking up. This is AB times the sine of 51.34. And this is AB times the cosine of 51.34. So if I look at my vertical forces only have one unknown. So AB times the sine of 51.34 plus 4.583 equals 0, where AB negative 4.583 over the sine of 51.34, and that equals 5.87 kips negative. Again, I've drawn it positive as if it's coming out. The negative sign means it's really pointing downward, so that means this is compression. Okay, now that I know AB, I can use AB and 5 to solve for AC. So if I look at my horizontal forces, I have a negative 5 plus AC plus AB, I know AB, times the cosine of 51.34. AB is negative 5.87. Okay, so I will have AC equals 5. I take the negative 5, move it to the other side of the equal sign, and its sign changes. Then I take my negative 5.87 and I move it to the other side of the equal sign, and I multiply it times the cosine of 51.34. And when I total all those up, I get 8.6667. I now know 2 of my 3 unknowns. And since that's positive, and it's pointing out of the pin, it's tension. And finally, point C. At point C, I have excuse me, I have 5.417 pointing upward. I have BC times the sine of 32.005 going this way. I have BC times the cosine of 32.005, and also going this way I have AC, which I know, 8.67 kips. Kips. In this case, I'm just going to look at the vertical forces. So I have 5.417 plus BC times the sine of 32.005. Those equal 0. So BC, and you knew this was going to happen, negative 5.417 over the sine of 32.005 equals, BC, 10.22. It's negative, so BC is 10.22 kips compression. If I draw it positive and I end up with a negative sign, it means it's in compression. And this is actually the correct way to write it. And there, AC, AB, and BC are the loads in my 3 nodes. Notice I didn't even need to use these, but if you can check it out, you'll notice that BC times cosine of 32 is 8.67. I'll let you actually verify that. And that is our final answer.